Hello everyone, welcome to my channel Chemistry is Fun. Today we will deal with the topic solutions. This is for class 12 and we are discussing it today for 2025-26 and this is part 1 of the topic. First of all, let us see what are solutions. Solutions are homogeneous mixtures of two or more than two components. Homogeneous mixtures of two or more than two components. Its composition and properties are uniform throughout the mixture. So all over the mixture we will get same composition and similar properties. There is a type of solution called binary solution. They are the solutions that have two components. So binary solutions have two components. The component that is present in largest quantity is the solvent. Solute refers to the other component that is present in smaller amount. So the higher amount, the quantity which is having higher amount is the solvent and the component present in smaller amount is the solute. Now we can have different types of solutions like gaseous solutions, liquid solutions and solid solutions. In case of gaseous solutions, the solvent is a gas. The solute may be a gas or a liquid or a solid. So we can have a gaseous solution of gas in gas, as in case of mixture of oxygen and nitrogen gases. We can have the solute as liquid and solvent as gas, as in case of chloroform mixed with nitrogen gas. We can also have solute is the solid and solvent as gas, as in case of camphor in nitrogen gas. The second type, which we call as the liquid solutions, it can be of three types. Solute is gas, solvent is liquid, as in case of oxygen dissolved in water. There may be the case where solute is a liquid and solvent is also a liquid, as in case of ethanol dissolved in water. Third type, solid in liquid. So solid in liquid is glucose dissolved in water. For solid solutions also there are three types. Solute, gas, solvent, solid, solution of hydrogen in palladium. Solute, liquid, solvent, solid. The example is amalgam of mercury with sodium. Solute is a solid, solvent is also a solid, as in case of copper dissolved in gold. So these are the types of solutions. Now we will see some ways in which we can express the concentration of the solutions. First one is mass percentage. Mass percentage is mass of component in solution divided by total mass of the solution multiplied by 100. This is mass percent. For example, if we say that there is a solution of 10% glucose in water by mass, it will mean that 10 gram of glucose is dissolved in 90 gram of water, so that there will be a 100 gram solution. It is used in industrial chemical applications. This concentration, mass percentage, is generally used in industrial chemical applications. Next is volume percentage of a component. That is volume of component by total volume of the solution multiplied by 100. Like 70% V by V solution of isopropanol means for every 100 ml of the solution, there are 70 ml of isopropanol. Next is mass by volume percentage. This is mass of solute dissolved in 100 ml of solution. Mass of solute dissolved in 100 ml of the solution. Next important, parts per million. Parts per million is number of parts of component divided by total number of parts of all the components into 10 to the power 6. Number of parts of component divided by total number of parts of all the components of the solution into 10 to the power 6. Now, the concentration of pollutants in the water or atmosphere is often expressed in terms of parts per million. It is used to express very small concentrations, as in case of dilute solutions. Also, as I told, it is also used to express concentration of pollutants in water or in atmosphere. Next is mole fraction of a component. It is number of moles of the component divided by total number of moles of all the components in the solution. So if there is a binary mixture having two components A and B, then mole fraction of XA is given as Na divided by Na plus Nb, where Na is the number of moles of component A divided by Na plus Nb, that is total number of moles of the components A and B in the solution. In a solution, if there are I number of components, then Xi will be Ni divided by N1 plus N2 up to Ni. Okay, Ni divided by N1 plus N2 up to Ni. And if we add all the mole fractions of all the components in the solution, we get 1. So x1 plus x2 up to xi equal to 1. This is very useful in relating some physical properties of solutions like vapor pressure with concentration of the solution. It is also useful for analyzing gas mixtures. It is also useful for analyzing gas mixtures. Next is molarity. Number of moles of solute dissolved in 1 liter of solution. Molarity is number of moles of solute dissolved in 1 liter of solution. It helps to determine number of moles of reactants and products involved in a chemical reaction so that we can do accurate calculation of the yields and the limiting reactants. Molarity helps us to know the number of moles of reactants and products which are involved in a chemical reaction. Thus, we can do accurate calculation of the yields and the limiting reactants. Next is molality. Number of moles of solute present in 1 kilogram of the solvent. And molality is a temperature independent measure of concentration. Temperature independent measure of concentration because it is based on mass, which does not change with temperature. Molality is preferred in calculations involving colligative properties because these will depend on number of solute particles and not the volume of solution. So molality is preferred in calculations involving colligative properties because these depend on number of solute particles, not the volume of the solution. I hope students you all could understand the topic which I discussed today. Thanks for watching my video. Please subscribe to the channel and share the video. Thank you all.